So what we have here now, around the turn of the century, are four engineering disciplines. And in a way, one can develop a thumbnail sketch of the history of engineering disciplines in the United States by extrapolating this simple formula into other fields. Basically, you take an existing field of engineering, an existing engineering discipline, you throw in a new science, and quite possibly out pops another field of engineering. So let's take a look at a few examples in order to explore this. The key point here is that in the United States, we have two family traditions, two descent lines, as it were, in engineering, with the majority of fields emerging from the descent line originating with mechanical engineering. And mechanical engineering, as you remember, was born inside of the shop. And so basically, most of the fields of engineering that exist in this country share a family tradition, a family history with labor, with workers in the shops. On the side of civil engineering, formed, growing in the early 19th century, still existing today, we find one other field that emerged, about which we've talked somewhat, namely mining engineering. Mining engineering was basically a combination of civil engineering, because of the structures, and geology, the science of geology. Continuing in the civil engineering tradition, not until recently do we find another field emerging, the field of environmental engineering, often growing out of civil engineering departments. There we see environmental engineering being basically a combination of civil and fields of ecology. On the mechanical engineering side, the field develops autonomously inside the shop in the 19th century. In the late 19th century, you take mechanical engineering, throw a little physics in, and you have electrical engineering, establishing a tradition that lasts up to the present, with an important change coming in a moment. Mechanical plus chemical gives you chemical engineering. Around the turn of the 20th century, the rise of interest in the social sciences, linked up with mechanical engineering, led to the founding of a field called industrial engineering. And then another field emerges in the first 2 decades of the 20th century that is uniquely positioned in a way between mechanical engineering and civil engineering, namely agricultural engineering, applying the sciences of agriculture, including biology, but also drawing upon structures, because often structures were constructed. And if you look at the history of agricultural engineering in the United States, you'll find sometimes it's positioned in unique ways in relationship to these other departments. As we travel through the 20th century, the development of interest in aeronautics led in the 1920s and 1930s, led to the establishment of aeronautical engineering. Following following Sputnik and the new interest in engineering sciences, we find the establishment and growth of fields or the discipline of engineering science and mechanics. A number of other fields grow up during this period, and you can trace, in most cases, trace their development as subfields growing out of mechanical engineering. One interesting case that's important to examine, in part because of its unique structure and unique trajectory, is the appearance of computer engineering, which was established in the early 1980s, in some places middle 1980s, in others. Computer engineering grew not out of mechanical engineering, but out of electrical engineering. You basically now take the tradition of electrical engineering, add in computer science, and out comes computer engineering. You'll see tensions inside of electrical engineering departments as some have struggled to hang on to computer engineering. Sometimes you'll see computer engineering peeling off as a separate department. What I find especially fascinating in the appearance of computer engineering is that it has left behind its historical relations to mechanical and civil in one important way, and that is computer engineering has pushed for the elimination of training, teaching in statics and mechanics, up until recently, up until, say, the 1990s, it was taken for granted that statics and dynamics were the key first steps into engineering education for all engineers. And when some engineers were given the authority, the freedom to learn their engineering without statics, it both produced a great outpouring of conflict inside of engineering colleges, but also marked a new trajectory for fields of engineering, which might lead to other new fields down the road, namely engineering responding directly to job opportunities in the marketplace. In conclusion, we can see that it's the trajectory of mechanical engineering, the descent line of mechanical engineering, that provided the major source of fields of engineering inside the United States. The mechanical engineer was born inside the shop, and hence most fields of engineering share this family history with wage laborers. You are connected together. So if you go off and work as an engineer in a factory or workplace and there are wage people working with you, they are members of your family too. Also, we see from this story that by the early 20th century, it's through the rise, expansion of mechanical and then electrical and chemical engineering, we see the institutionalization of a system where engineers work as employees inside of big companies and, in a way, begin the process of making ourselves, invisible. Do engineers hence become revolutionaries? No way. Do they become people who are even supportive of unions, the unionization movement? Pretty much no way, because the engineers locate themselves on the side of management. As Peter Meiksins, a sociologist historian, has argued, most engineers during this period, extending to the present, were basically thinking of themselves as white-collar workers seeking a middle-class status. As we moved through the 20th century, the Fordist period, this category was pretty stable. The Cold War did play a key role in increasing the importance of the mathematically based sciences, but it was not until the Cold War was over, to the period in which, let's say, a period defined by the concept of competitiveness and now globalization, that the question of priorities in engineering education has been re-raised and is leading to all sorts of reforms in engineering education, especially in the United States. For more information on this contemporary period, take a look at the module that explores reform movements in engineering. Thank you very much.